Hello AP Chem. This video is going to be showing you how to do Unit 3's FRQ review, the second one that I assigned you, which is the 2008 FRQ problem number 2. Just so you're aware, the redesign did not happen before this problem was released, so what you will probably be seeing is a problem that is a lot of stoichiometry, but not anything else. And as you know, the problems now are a little bit more integrated, but I really like the problem, and I think it does a good job of reviewing some of the stuff from Unit 3, so we're going to do it anyways. I got so excited, I just threw my pen right there. Let's get started, and we'll see how things go. It says, for the start of our prompt, answer the following questions relating to gravimetric analysis. Gravimetric analysis is where we filter something out and weigh it using gravity. That's where the gravimetric comes from. The start of our prompt says, in the first of 2 experiments, a student is assigned the task of determining the number of moles of water in 1 mole of MgCl2, NH2O, N being the number of moles. The student collects the data shown in the following table. This, by the way, means that this is probably an empirical formula problem. We've got this lovely table here, mass of the container, mass of the sample, mass after we heated it the first time, second time, and third time, which you know if we have time, we go through and we heat things a million times, but we never do. If we look at A, it says, explain why the student can correctly conclude that the hydrate was heated a sufficient number of times in the experiment. It was heated 3 times. If we look, the mass went from 23.982 down to 23.976, and then 23.977. These last 2 heatings here are the clue to let us know that things are done. And because they remain constant, or relatively constant, then we can say that it's done. So that's what I'm going to say. Because the mass stays almost constant between heatings 1 and 2, let me back that up, not heatings 1 and 2, heatings 2 and 3, we can say it is heated enough. All right, so that one, not too shabby, pretty fast. Okay, moving on to B, it says use the data above to 1, calculate the total number of moles of water lost when the sample was heated, and 2, determine the formula of the hydrated compound. So we got a lot of kind of stuff going on here. I'm going to take care of 1 first and figure out the moles of water lost when the sample is heated. If I look, the difference after I heat the mass from where I start, 25.825 grams, to 23.977 grams, that mass goes down. And we know that if we heat a hydrated compound, the water leaves that hydrated compound. We did this lab way at the beginning of the year. And so what I'm going to do is I'm going to use those pieces of data from earlier in the problem. What I need to do is I need to take the mass of the sample and the container, which is 25.825 grams, and then I need to take that number and subtract from it the mass after my third cooling, which is going to be 23.977 grams. And if you subtract those and put those into your calculator, you should get a mass of 1.848 grams of H2O. Now it's asking you to take those grams and then convert them into moles of water, so that is what I'm going to do. 1 mole of water is 18.02 grams, and that leaves me with 0.1026 moles of H2O. That should not be super difficult. So question A should be 1 easy point. Question B should be 1 easy point. B2, though, is a little bit more work, because what you need to do is you need to figure out the formula of the compound. And so what we're doing is we are figuring out the ratio of the MgCl2 talked about earlier in the prompt, the MgCl2, and then we need to figure out the N of the H2O. And if you remember with empirical formula, what we need to do is we need to do a ratio of the chemical here to the number of waters. So we need to take them and divide them by the smallest number of moles. But that means that we need to find the moles of MgCl2 first. To do that, if we go back and look at our data, I feel like I'm sliding this back and forth, and I apologize. We have the mass of our empty container, and then we have the mass of our stuff before we heat it, and then after we heat it. And the important part here is being able to recognize what is the relevant data that we are going to be using. So we need to figure out the mass of just the MgCl2, and that's it, so without the water. So in theory, after this third heating, what I have is the container and only the MgCl, because I've driven all of that water away. So that's what I'm going to do first, is I'm going to figure out how much MgCl2 I have. I'm going to slide my paper back up here and do the work. You can look at the table on yours at home. So what I need to do is take 23.977 grams. That's my final mass. And I need to subtract from it 22.347 grams. That is the original container. And in theory, all I need to do is subtract those two, and I should have my mass of MgCl2. That mass comes out to be 1.630 grams. The difference between those two. So this is how many grams of MgCl2 I have. Now I need to get moles of the MgCl2. 1 mole of MgCl2 weighs 95.20 grams. And when I do the math for that, I end up with 0.01712 moles of MgCl2. So now, essentially, I've got an empirical formula problem. And what I want to do is I want to divide by the smaller number of moles. So I'm going to take the MgCl2. Sorry, you'll hear my dog barking in the background. I'm going to divide that by itself. And then I'm going to divide the moles of water by that same number of moles, 0.1712 moles of MgCl2. So these obviously cancel out and you end up with 1, which makes sense. And then you get, for this number, approximately 6 moles of H2O. And what this tells me is that I have, for every 1 mole of MgCl2, I'm going to have 6 moles of water that are in the compound. So my formula is actually MgCl2, and then the little star or a dot, and then 6 H2Os. Okay? Scoring on this, you'd earn 1 point for getting the number of moles of water, 1 point for figuring out the moles of MgCl2, and 1 point for showing work to get the correct formula. All right. Question C says that a different student heats the hydrate in an uncovered crucible and some of the solid spatters out of the crucible. That is why you're supposed to heat it gently. This spattering will have what effect on the calculated mass of water lost by the hydrate? Justify your answer. So think about this. Got my little, we'll assume it's a crucible. Got my container, and then some of it flies out while you're heating it, but before you take your mass. What's going to happen is the spattering will increase the mass lost. Does that hopefully make sense to you? So as the chemical spatters, more mass is lost than is supposed to be. Okay, so as the chemical spatters, more mass is lost than is expected. What's going to happen is this will result in a higher mass of water calculated than actually left. So even though I kind of talk about it as far as the chemical causing a mass, I need to be specific and round it back into the original question. So it's going to talk about a higher mass of water that's lost. Okay. So that is C. Here comes that second experiment I know you were all super excited about. It says in the experiment, a student is given 2.94 grams of a mixture containing anhydrous MgCl2 and KNO3. To determine the percent mass of MgCl2 in the mixture, the student uses excess AgNO3 to precipitate the chloride ion as AgCl. Starting with the 2.94 gram sample of the mixture, briefly describe the steps necessary to determine the mass of precipitate. So they are talking about you've already started by putting the sample into the MgCl2 into the mixture, and now they're asking how are you going to make that precipitate first of all, and then collect the precipitate. You could write this as a bulleted list if you wanted to. I would think that would be preferred rather than writing a full paragraph. So the first thing you need to do is you need to add silver nitrate. You have to add that, otherwise, you're not going to get any precipitate. Once you do that, your precipitate's going to form. You're going to let it settle on the bottom. Then you need to filter your precipitate out. So you're going to set up your filtering apparatus, run the filter, all the silver nitrate hopefully has reacted and you have the silver chloride precipitate, so you're going to filter that. Then you wash your precipitate. So you always wash the precipitate off and then you dry it. Put it in an oven overnight to get all the extra water out, and then you have to weigh the precipitate and the filter paper at the end. Okay, for the scoring on that, it says 2 points are earned for all three major steps: filtering the mixture, drying the precipitate, and determining the mass by the difference. So what they mean, weigh the paper and then subtract the filter paper. Okay, so the washing, not so important, but the drying is super duper important because it gets out all of the excess water. Moving on to question E, it says the student determines the mass of AgCl precipitate to be 5.48 grams. On the basis of this information, calculate the following: the number of moles of MgCl2 in the original mixture and the percent by mass of the MgCl2 in the original mixture. So what I need to do for part 1 is I need to figure out the number of moles in the mixture. And I have a mass of my AgCl here, and I know what my reaction is going to be, or I should be able to figure that out. And so I should be able to figure out through stoichiometry what that amount is going to be. Okay. So if we look at my balanced equation, I have AgNO3 plus MgCl2. And if we think about a double replacement reaction, you are going to have Ag with the Cl and the Mg with the NO3. If we check our oxidation numbers, Mg is a +2, NO3 is a -1, so my formula needs to be MgNO3 2. Do I think they're going to make you write an equation on the test? I'm not 100% sure. They've been moving towards giving you the equations to prove that you know how to do the math, but I guess it's not going to hurt to be able to do this. So Ag is a +1, C is a -1. That is a good formula, but the equation is not balanced. So what I need to do is I need to, if we look here, I've got 1 silver, 1 silver. That's good to go. Nitrates, though, got a problem. So I'm going to put a 2 on my silver nitrate on the reactant side, and then that is got to be balanced out by a 2 on the product side in front of the silver chloride, but I think that is good to go. All right. So what I want to do is I want to figure out, starting with my mass of AgCl, I have 5.48 grams of AgCl. And I want to get to moles of MgCl2. So what I need to do is convert my grams of AgCl to moles. 1 mole of silver chloride weighs 143.32 grams. And then if I want to go to moles of MgCl2, for every 1 mole of MgCl2, I have 2 moles of AgNO3. And when I put that into my calculator, I will double check just to make sure. 5.48 divided by 143.32 divided by 2 gives me 0.0191 moles. You might see a little bit of, or hear a little bit of an inflection in my voice that's saying, why does she sound like she doesn't know what she's doing? I'm looking at the answer key, and I feel like the mole ratio that they have on there is kind of dumb. So I think they're adding extra work when they really should just be doing some stoichiometry. I think they're trying to get around the fact that they don't give you a balanced equation, but if you're smart enough to do the balanced equation, then it's just basic stoichiometry. Okay, so back to number 2. It says that the percent by mass of MgCl2 in the original mixture is the next thing we need to calculate. So what I need to do is I need to figure out how many grams of the MgCl2 I have, and then I'm going to compare that to the original mixture. So if I have 0.0191 moles of MgCl2, I need to get that into grams, and that's going to be using the molar mass, and there are 95.2 grams of MgCl2 for every 1 mole of MgCl2. When I put that into my calculator, I take the 0.0191 moles of MgCl2, multiply it by the 95.2 grams of MgCl2, and then I end up getting 1.82 grams of the magnesium chloride. So that is how many grams were in the mixture. If I want to find my percent composition, what I need to do is I need to take the mass of my MgCl2, which is 1.82 grams, and divide it by the whole mass of my mixture, which was a long time ago, but weighed 2.94 grams. And then I'm going to multiply that by 100%. And when I do that, I get 61.9% by mass. Hopefully that clears things up. I hope that you're seeing that sometimes the answer key isn't always the easiest way to solve things, but it doesn't mean that you're doing things wrong. So if you feel like you're stuck, but you know that you did it right and you're not sure about your work, videos are a good place to check. If you have any other questions, please come to a meet or shoot me an email and we can get things cleared up. Thanks.